Okay, 2012 AP Calculus free response number 2 from the AB test, and it's one of our standard area and volume problems. Sort of standard. Part C is a little bit interesting. But it says, let R be the region in the first quadrant bounded by the x-axis, the graph y equals natural log of x, and y equals 5 minus x, as shown in the figure above. Find the area of R. And there are a few ways to deal with this. I mean, I could flip this around and find the area as an integral dy going across, going from 0 to whatever this is. But probably the easiest way is to figure out where these two graphs intersect, splitting this into two regions, one of which has an area over here that is bounded on the top by that natural log function and the bottom by the x-axis, and the other one whose area is over here, bound on the top by the line and on the bottom by the x-axis. So we can start off by just graphing, clear that stuff off, graphing y equals the natural log of x, and graphing y equals 5 minus x. And then, once this shows up, I can use the calculator to find out where they intersect. So I'll go over. So the first curve, I'm on my first curve, I'm on my second curve, I'm close to where they intersect, and it tells me the intersection is at the approximate point 3.693441 and 1.306559. And something for the AP Calculus test to know is we should not round that until later on. So what I'm going to say is this, okay, so 3.6934414. So 3.6934414, and then the y coordinate, which actually isn't important for the rest of this problem, but I'll put it down, 1.3065586. So 1.3065586. All right. So what I'm going to do is, in the calculator, I'm going to take this value, 3.6934414, and store that in the variable a. And I'll write that on the thing saying, let a equal this, and in all of my calculations using a, I include that. So let me go to the calculator and do that. So I'll quit out of here. And nice thing, I don't even need to type it all in because it's already stored in this X variable. It even has a little bit more precision than what I have over here. So I will just store that in the safer variable a. X is used for multiple things. We'll use it again. A isn't going to change unless I change it. Okay? So now, on to the actual problems, and I'll use this for B and C as well. Find the area of R. So I'm actually going to do two integrals. I'm going to do one integral, so area is equal to the integral from 1 to this a of the natural log of x dx, because that's what defines the top of our first region, plus, and then the second region, integral from a over to 5 of the function here. This defines the top 5 minus x of that one. So, plus the integral from a to 5 of 5 minus x dx. And I could go after this getting antiderivatives till the cows come home. Doesn't matter. I'm still going to round it off to 3 decimal places. So I'm just going to put in the calculator. You could get an exact answer, or a more exact answer, I guess. A is still an approximation. So here we go. Math 9, so the numerical integral of the natural log of x as x goes from 1 to a, don't need to type that value in all over again, plus the numerical integral of 5 minus x as, as x goes from a to 5. Okay, make sure I add it down. So natural log of x is x goes from 1 to a. Natural log of 5 minus x is x goes from a to 5. Evaluate that, and I get this answer, approximately 2.985804105. Okay. So, I double check to make sure that's what I got earlier, so I'm not making an error. Lovely. And this I can round to 3 decimal places, so I'll round this off to 2.986. And that's the area of R